Hi, my name is Régis and this is Sheriff. I am the CEO of Sailendra. Sailendra is a company born from research. We are coming from a laboratory in Nancy called L'Oréal, and we are coming from India. Basically, I will do introduction, transition, and conclusion, and Sheriff will do all the work and talk about recommendation. So the main sector of Sailendra is personalization and recommendation. We are coming from artificial intelligence, so we are doing machine learning, behavioral analysis, and recommendation.
Okay, so we have, I would like to present for you our solution for recommendation, which is more or less a tailor-made solution. So it's not that recommender systems need digital rates or from users. As for us in the industry, we cannot ask users to do more effort to rate every element or every item that they visit on the web. That's why we decided to collect traces ourselves, the traces of the user, and to convert them into the digital ratings. So for our clients, we add some Java code and some indexing in their websites that allow us to collect the information, what did the user do on their websites. So if the user visited a category page, a product page, if he added some product to the basket, if he passed a long time in watching a product, or if he came to watch the same product or the same category many times. So we collect all this information, and then we convert these traces. We have an algorithm that convert these traces into user item digital ratings. The next step is that we choose the appropriate algorithm for the user, for the case of our client, because we don't recommend a film or a movie like we recommend a car. We are completely into different domains. If I watch a movie and I don't like it, it's not a problem, it's not the end of the world, but if I buy a car and I don't realize then that it's not good for me, it's a problem. I have paid a lot of money for something which is not good. So principally, we have the user-based recommender systems or algorithms, which consider that two users who have nearly the same history or have a similar history will have a similar future too. We have the item-based recommenders, which consider that if I like an item, I would like the items which are considered similar for it. Knowing that the word similar is different from a system to another. So, for example, a similar user in collaborative filtering are the users who rate the same items, whereas in a trust-based recommender system, they are the users who trust each other. For the item-based, I have the content-based, which means that items that have the same description are similar, or the item-based collaborative filtering, which consider that items which have been seen by the same users are similar. Okay. And finally, we have the hybrid algorithms, which are a combination of many systems or many recommender algorithms. So this is the third step. The fourth one in our system, which is, we don't do that for all our clients, but we do that for some of them, it's to add new algorithms to our catalog or to adapting to their domain of activities, such as marketing filters, which I will explain in more details later.
Okay, in order to demonstrate these programs, we will show you three different clients, three different cases, and from three different domains. The first one is Paraform. It's a parapharmaceutical website. The second one is Gillier. It's a B2B website, and they sell drinks to bars and restaurants. And the third one is before bank, so online banking. First case.
Starting with Paraphone, which sells pharmaceutical products online. The problem was that they had a low user conversion, and their objective was to realize additional sale, which is a classical case for e-commerce.
Yeah, this is a very classical case for us.
Yeah.
This is just e-commerce.
Yeah, so the method that we used is to generate recommendation using different algorithms, as I explained before, according to the visited page, or to the type of the visited page. For example, in the product page, the goal when the user arrives to a product page, the goal is to propose for him alternative options to augment his satisfaction. If he is not enough satisfied with this item or product, he can see other products. So what we choose to do with that, always our choice are in the accord with our client, because he also knows his domain better than us. But we can also propose for him. So we proposed a cascade hybrid recommender, which will try to find content-based similar items to the consulted item. And then it will make an item-based collaborative filtering. So he will see if any of these items were consulted or bought with this item. Sorry, this is the third one. So we have a combination of three types of recommender system to recommend 3 products. Then in the basket page, where the user has already choose what will he buy, in this case, I will try to make him buy another thing to complete his basket. And in this case, I will focalize more on the product which were bought with the current product. And I will add popular products within the community of the active user. So I will cluster users and find this user, he is in which cluster, and try to find a product which are usually bought by this category of users. The final result for us, it was a 20% plus of conversion on this website.
So on this case, we just try to imitate human behavior. If you are going into a store in the street, the people that are here has several strategies to serve you. He can say, okay, you like these shoes, so I will propose you these shoes. Okay, so when you are on the, I don't remember the word for the caisse, cash machine, the people who sell the shoes can sell you lacet, or, sorry for the word, or cirage. This is the same thing. Depending on the place on the website, depending on the people, you are not using the same kind of algorithms. So the second case is Gimilier. I said earlier that this is a company that sell drinks to bars and restaurants, and this is a B2B company. So there are problems that there are local versions on sales channels. There are teleoperators, and we provide recommendations to teleoperators in order that they sell a lot of products to their clients.
So as Régis said, it's a little bit a special case, which we don't see every day. In this case, our recommendations were directed to the tele-vendor, so to the person who is selling products to the final client or to the bar. So we had to develop some tailor-made filters to add them on the results of our algorithms to be suitable for this case. Knowing that some of their clients have constraints, such as some restaurant cannot sell alcohol. They have no license for that. Some, when they sell beer, they need to sell the Heineken beer because they have a contract with Heineken, or with the Kronenberg, or with other producer of beer. So we cannot recommend for them the beer of the concurrent. So in this case, we had a lot of content, but with the development of our, with adding these filters to our algorithms, we could, and we had another algorithm of user clustering based on the behavior of the user, not only on the description of the user. We mixed two things, so the description of the user and his behavior, because it's also a question of bars in the city do not have the same thing like bar in outside the city or in further places. So we adapted to that, and according to our client, he now has more better customer knowledge for his televendors. And his sales were increased, and according to him too, we could propose innovative recommendation despite the presence of the strict rules that were imposing to us.
These particular algorithms also use meteorological information and time in the years. If it's you are not selling the same drinks in July and in December. The third case is online banking, and this is before bank. And their direct problem was we have a lot of data, we have a lot of navigational information. What can we do with it? The main objective is to simplify and understand users' navigation and to get some very important information, such as does this customer will churn? Does it will it resiliate his account? Okay. We try to predict this kind of behavior.
So we, in this case, we proceeded to analyze and cluster the stream of user based on their behavior and on which parts of the site they prefer to go, which parts that they don't ever go. So using the history of navigation of users, we could construct some clusters, and we could communicate this result to the bank, saying that you have users that do this, this, and this, and what will you do for them? And it's the bank that decided the strategy. We just provided the description or of the user behavior, and it was up to the client to see, okay, I will do that with this group of users, or I will do that with this cluster. So some of the results of this case were to optimize the user navigation and simplify his path. Because sometimes the bank found that users go visit 8 pages, for example, whereas they could do the same thing visiting 5 pages. So they could reorganize their website in order to optimize the user path. We could predict some intention of users and their time. So to say that this user in 15 days will do this thing. So we could also communicate that to the bank. Or in 3 months, this user will have a livret A, or will stop his livret A, or will do something, just by using his navigation on the website of the bank. So the bank could anticipate some cases like customer attrition, and we could our system can alert the bank, and the bank can anticipate this kind of behavior of the user to keep them in the bank. And also now the bank can adapt his marketing and communication strategy according to the community of users. So these are the main results. There are many others because we have many clusters in this case, but these are the principal clusters.
Okay.
We also work in other domains, like e-health. We have a project which is Sailendra. It's not. We are a partner in this project. So the goal of the project is to secure sick and old persons in their places. In this project, there will be a robot and a tablet application which will try to keep the person safely and try to detect if the person will fall in his place, or it's the function of the robot to observe the person. As for the tablet, it's just for observing his daily activity. Like if he weights himself every day, if he brushes his if the doctor asks him to do something, if he do everything or not. Our role as Sailendra that we will personalize the interface of the tablet in function of what this person, how this person uses his tablet, knowing that it's very difficult with all persons, they are not used to this kind of technology. The other thing is to push some personalized behavioral advices for their activity, which is in the domain of health, but it's not really medical. We cannot do this for medical things. And it will be with the cooperation of medical staff. The last domain is the e-learning. We are also with the University of Lorraine in the project Pericles, which where the goal is to recommend and personalize pedagogic resources for students in the university. And that's by integrating a framework within the website of the university. And our role as Sailendra is to participate in the conception and the parametering of recommendation algorithms, with also always with the L'Oreal laboratory, and also to industrialize the resulting algorithms of the project.
Thank you, Sharif. So the conclusion is very simple. You cannot use the same algorithm for any case. You have to create or to use algorithms. You have to use marketing rules, to use marketing filters in order to have a very good performance. If you sell cars, you have to sell the good car to a person, but you have to remember that this car is better for you because you are earning a lot of money with this one and not with this one. So you have to personalize